Forensic fingerprint analysis is a subfield of forensic science that deals with the examination and comparison of fingerprints to identify individuals. It is based on the principle that every person's fingerprints are unique and do not change over their lifetime. Fingerprint analysis involves collecting and preserving fingerprints from crime scenes, comparing them to known fingerprints from suspects, and determining if there is a match. This evidence can be used in court to help identify suspects and link them to a crime. Forensic fingerprint analysts use a variety of techniques to enhance and compare fingerprints, including 1. Visual examination involves comparing the ridge patterns and details of two fingerprints to determine if they are from the same individual. 2. Latent print analysis involves the enhancement of faint or partial fingerprints to make them visible for comparison. 3. Automated fingerprint identification systems, AFIS, uses computer algorithms to compare and match fingerprints with those in a database. Forensic fingerprint analysis is widely accepted as a reliable and scientifically valid method of identifying individuals and has been used in criminal investigations for over a century. There are three main types of fingerprints. 1. Arch. These fingerprints have a raised ridge line that runs from one side of the fingerprint to the other, without any furrows, ridges, crossing it. 2. Loop. These fingerprints have a ridge that enters on one side of the fingerprint, recurves, and exits on the same side. The majority of fingerprints are loops. 3. Whorl. These fingerprints have at least two deltas, which are points where the ridges end and diverge, and form a circular pattern. In addition to these main types, there are also subtypes, such as double loop, central pocket loop, lateral pocket loop, plain whorl, accidental whorl, and composite. These subtypes are characterized by specific ridge formations and are used to further classify fingerprints for the purpose of identification. Forensic fingerprint analysis typically focuses on the specific ridge patterns, minutiae points, and ridge characteristics that are unique to each individual. These patterns and characteristics are used to compare and match fingerprints to identify individuals.